Right, so let's look at this question where we are going to. So now, first of all, we need to know the direction of flow. So the direction of flow, right? Now, looking at the head, realize that here the water level is at this side, so the flow is going to be in this direction. This water, right? Right. Now, the water head here and the water head here are two different. Do you get it? So this has a higher head. So this will be the direction of flow. The direction of flow is going to be in this direction. So with that in mind, let's see what the question with knowing the direction of flow very important. So first of all, they say we should find a pressure head, elevation head, total head. Then in this case, we are supposed to find stresses. So let's take the first point. So I'll take point A for instance. So point A, we are supposed to find a total stress there, which is equal to the pressure head plus the elevation head. Now, pressure head at point A is zero because there is no column of water above A, right? Now, this is our D2. So this is our D2. And so the elevation head at A is equal to. So from here, let me change the color. So from here to here is 5. Then from here to here is 2, right? And so we are going to get 5 plus 2, which is what? 7. And so the total head at A is what? 0 plus 7. So the total head at A is what? 7 meters, right? And that same A, we are supposed to find the total stress. So the total stress is 0 because there is nothing above A, right? Now, the pore water pressure is equal to the unit weight of water times the pressure head. The pressure head is 0, so the pore water pressure is also 0 at A. Then the effective stress, which is given by the total stress at E minus the pore water pressure at E. And everything is 0. So the total effective stress at E is also what? 0. Right. Now let's go to point B. Right. Now point B, we need to find the total stress there. It's equal to the pressure head. Now this B. So point B, pressure head at B plus the elevation head at B. Now the pressure head at B, the column of water above it. So this is a soil, right? Because this is water. The column of water above point B, and that is for 2 meters. Then the elevation head at also B is also from here to B. So from the B2 to B is what 5 meters. And so the total head will be equal to 2 plus 5, and that will give us 7 meters. Now we have to find a total stress at B. So at B, what is the column of material sitting on top of that? Is water. So we need the unit weight of water times the height there. So the total stress at B, unit weight of water. So let me give the unit weight saturated of soil is 19 kilonewton per meter cube. Then the unit weight of water, we are taking it to be 10 kilonewton per meter cube, right? So in this case, the unit weight of water is 10 and the height is 2. And so the total stress there is for 20 kilonewton per meter square. Now let's find the pore water pressure at B, which is equal to the unit weight of water times the pressure head at B. The unit weight of water is 10, pressure head at B is what? 2. And that's also 20 kilonewton per meter square. Now the effective stress at B is equal to the total stress at B minus the pore water pressure at B. That is what? 20 minus 20. Now give us what? 0 kilonewton per meter square, right? Then we can come to point E. The reason why we are going to point E now here is that we're going to point E now here is that this is a soil. I told you from the first example that we saw that when you are dealing with situation like this, deal with the boundaries first before you go to the inner. That's why we have jumped to E. So with E, first of all, we need the total head at E, which is equal to the pressure head at E plus the elevation head at E, right? Excuse me. So with that in place, um, the pressure head at E is equal to the column of water above it. So this is E. The E is here. I can bring it here. You don't find it using this side. No, you find it using this side. So the column of water at E is this. And that height is what? Is equal to this height here. And so it is what 5 meters. So the pressure head there is what 5 meters. Now E is on the elevation. So the elevation head is 0. So the total head at E is equal to what? 5 plus 0. And that will give us what? That will give us 5 kilonewton per meter what? Square. I'm sorry, 5 meters. The unit is meters. With that in place, we have to find the total stress at E. So this E, things that E is carrying. So this whole material, is what E is carrying, right? That's the whole material. So E is carrying the soil and the water. So the gamma sat times the height of the soil plus gamma of water times the height of the water. So the total is equal to what? Gamma sat is what 19. The height of the soil is 5 plus gamma of water. So we are going to have here to be what 10 by 2, right? And so the total stress here is 95 plus 20, right? So 95 plus 20 is going to give us 150 kilonewton per meter watt squared. Then we have to find the pore water at E, which is equal to the unit weight of water times the pressure head. The unit weight of water is 10, pressure head there is 5, and that will give us what? 50 kilonewton per meter watt squared. Now, if you want the effective at E, is the total at E minus the pore water pressure at E. So the effective at E, the total is what? Total we have 115 minus 50, right? So the effective is this. So let me get my calculator and see. So 115 minus 50, and that's what 65 kilonewton per meter. So this is the effective, this is the total, this is the pore water pressure. Now we have to look at the D and E. So very important. I want to clear this portion to find the E and the C and the D. Very important. Okay. So we got to realize that the direction of flow is downwards, right? Downwards. So when the head was at A, it was 7 meters, right? When it was at B, it was 7 meters. But when it got to E, it went toward 5 meters. So from 7 to 5, we can find the head loss. So we want to know the head loss between B and, sorry, between here, B and C. But the total head at B minus the head at what? At E. The head loss is between B and E. So as the water moved through the soil from B to E, it was having, as when it was at B, it was having a head of 7. When it got to E, the head changed what? To 5, means that there has been an head loss. So we want to know the head loss. So 7 minus 5, and so the head loss between B and E is what? 2 meters. Now I want to find the hydraulic gradient that is equal to the head loss over the entire length. So the hydraulic gradient will be 2 over 5, and that's 0.4. So every meter there's a loss of 0.4. Now the direction is from here to here. So when it moved 2 meters from B to C, what was lost? So I want the head loss from B to C, which is 2 meters, which is equal to the hydraulic gradient times the length, which is 2. So the hydraulic gradient was 0.4, the length is 2. So we are going to get 0.8, right? So the head loss between B and C, which is given by the total head at B minus the total head at C, and this is 0.8, which is equal to total head at B was 7 minus HC. So the head loss is equal to 7 minus 0.8. So the head loss is what? 6.2. Now, if the head loss is 6.2 at C, pressure head at C plus what? Elevation head at C. Now, what is the elevation head at C? It's from what? The datum to here. So that is what? 3 meters. Because from here to here is 2. And from here to here is 5. So that will be 3. So that is 6.2 equal to pressure head plus 3. So pressure head is equal to 6.2 minus 3. The pressure head is equal to 3.2. So with that in place, we can now find our total phase at C, which is the column of material sitting on top of C. So gamma sat times the height plus gamma of water times the height. Gamma sat 19. Height is what? Height is 2, right? Plus 10, height is 2. So we are going to get 34 plus 20, and that will be 54 kilonewton per meter squared, right? So the core water pressure at sea is going to be gamma of W times the pressure head at sea. You get it? So 10 pressure head 3.2, that will give us 32 kilonewton per meter squared. Now let's find the effective force at sea. Total minus core water pressure. Total is 54, core water pressure 32. The effective stress would be what? 54 minus what? 54 minus what? 32. And that would be what? 22 kilonewton per meter squared. So we are going to get 22 kilonewton per meter squared. That is for point C. Now let's look at point D. And let's see point D. Alright, so let's look at point D. So before we can find anything at point D, we have to know the head loss at that point, right? Remember the direction is from B to D downwards, right? So we want to know the head loss between point B and what? D. Remember that we found the hydraulic gradient between B and E over the length of the soil. We had 2 over 5, which is 0.4, right? And so we want to know the head loss from B to D, right? Which is at a distance of what? 3 meters. Is it 3? No, 4 meters. Because from here to here is 5. Let me do this. From here to here is 5, right? Then from here to here is 2. And from E to B is 1. Meaning that in between B and C is also 2, right? So the length between B and D is 4. That's 4 meters. So we want to know the head loss between B and D. And the length between B and D is what? 4 meters. So this is equal to I times what? The length between B and D, right? So the head loss between B and D will be equal to what? 0.4 times what? 4, right? And that's what? 1.6 meters. So that's the head loss. So we also know that the head loss between B and D will be equal to the head at B minus the head at what? D, right? And this is 1.6, which is equal to head at B is what? 7. We are looking for head at D. So the head at D will be equal to 7 minus 1.6, and that is head at D will be equal to 5.4 meters. Let me verify with my calculator. So 7 minus 5.4. So